Trigonometric ratios of special angles, that is 30 degrees, 45 degrees, and 60 degrees. Now, these three angles are special angles, and we can get their trigonometric ratios from triangles with special features. Now, for angles 30 and 60, so this is just for angle 30 and 60, consider an equilateral triangle with sides 2 units. So an equilateral triangle is a triangle whose sides are equal and the angles are equal. So each angle is 60 degrees and each side is 2 units. Now, if the triangle is divided into 2, so if we create some height here to divide this triangle into 2 so that we can obtain a right angled triangle. Now, this angle has been divided into 2, therefore its value is now 30. This one remains as 60. This side remains as 2 units. Now, half of this is half of 2, which is 1 unit. Now, for us to be able to find all the three trigonometric ratios, we will need to find the value of h. Therefore, to find the value of h, we use the Pythagoras Theorem. Now, h will be given by 2 squared minus 1 squared, and then we find the square root. And that is equal to the square root of 2 squared is 4 minus 1, which is equal to the square root of 3. Therefore, the value of h is equal to root 3. Now, with the three sides, we can find the sine, cos, and tan of the two angles. Normally, sine of an angle is given by the opposite side over the hypotenuse. The cosine of an angle is given by the adjacent side over the hypotenuse, and tan of an angle is given by the opposite side over the adjacent side. Therefore, sine of 30 will be equal to the opposite side over the hypotenuse. The opposite side to 30 is 1 over the hypotenuse, which is 2. Cosine is adjacent over hypotenuse. The side adjacent to 30 is root 3 over the hypotenuse, which is 2. Tan of 30, opposite over the adjacent. The side opposite to 30 is 1 over the adjacent side, which is root 3. Then for angle 60, the sine of 60 is equal to the side opposite to 60 is root 3 over the hypotenuse side, which is 2. The cosine of 60 is the side adjacent to it over the hypotenuse. The side adjacent to 60 is 1 over the hypotenuse, which is 2. Then tan of 60 is equal to the side opposite to 60 is root 3 over the adjacent, which is 1. And this is equal to root 3. Therefore, from this triangle, we have been able to obtain the trigonometric ratios of angles 30 and 60. Now, to obtain the trigonometric ratios of angle 45, we will consider a different triangle. So, for angle 45 degrees, consider an isosceles right-angled triangle with the equal sides equal to 1 unit. So, if this is a right-angled triangle and the two sides are equal, then these two angles should also be equal. And the two angles have a value of 45 degrees. Now, this side is 1 unit, this side is 1 unit. So, to find the value of this side, we use Pythagoras Theorem. So, x will be given by the square root of 1 squared plus 1 squared which is equal to the square root of 2. So this side is equal to root 2. Therefore, we can get the sine of 45, cosine of 45, and tan of 45. Now, sine of an angle is given by the opposite side over the hypotenuse. Cosine of an angle is given by the adjacent side over the hypotenuse. Then tan of an angle is given by the opposite side over the adjacent side. Now you can use any angle 45, there will be no difference. So with respect to this angle 45, to obtain sine 45, we take the opposite side, which is 1, over the hypotenuse, which is root 2. Cosine of 45, we take the adjacent side, which is 1, over the hypotenuse. Then tan of 45, we have the opposite side, which is 1, over the adjacent side, which is 1, and this is equal to 1. Therefore, we have the trigonometric ratios of angle 45. Now, an example of application of this knowledge. We are required to find the value of sine 30 plus cos 60 over the tan of 45. Now, from the previous work, we have obtained the sine of 30 to be equal to a half, the cosine of 60 to be equal to a half, and the tan of 45 to be equal to 1. Therefore, you just substitute the values and then add and divide them. So a half plus a half is equal to 1 over 1, which is equal to 1. Therefore, the value of this is equal to 1, and that is the answer. Now, having discussed the important points in this topic, next we will discuss the past KCSE questions that have been tested from this topic.